Hey folks, this is Joel, and in this particular video we'll continue with where we left earlier. We talked about VRFs earlier, and now we are going to extend that particular concept to VPNs, right? So in this particular video we are going to look at what you call as VRF aware VPNs, site to site, right? Okay, so the objective here is basically that the routers R1 and R2, which are over here, they should encrypt the traffic, right, for a particular customer. Let's do it for, say, customer A, right? So the routers over here, R1 and R2, should encrypt the traffic which is going from 10.11 to 10.22 and vice versa, right? So that's my objective. Okay, so we have seen the VPN configuration in earlier videos as well. It involves mainly the 5 steps. The first is your phase 1 configuration, then you do phase 2, then you define an ACL to help you find the interesting traffic, and then you put a cryptomap, and once you have done that you go and apply this cryptomap on a interface, right? But if you look at this particular setup over here, we earlier discussed that R1 and R2, they are going to have something called global routing table as well as a VRF routing table, right? The VRF routing table would be different for different customer, right? Here we have 2 customers, so 2 VRF setup, and there will be 2 different routing tables, right? Now if you look at the phase 1 setup, right, the phase 1 ISAKMP setup, we need to set up a secure tunnel during my phase 1 so that my Diffie-Hellman keys are exchanged, which are in turn used for phase 2. And so during phase 1 all my exchange happens by referencing an IP address. Okay, so I think you would have I think you might remember this particular command where we say crypto ISAKMP, then you define a key, right, and then you put in a key, secret key, and then you write address, and then you write the address of R2, right, and on R2 you do the same thing and reference the address of R1. Right now this is going to be difficult because all these address referencing was happening with respect to the global routing table, but we don't have anything in the global routing table here, so we need to use the VRF routing table, right? Great. So now let's start with the configuration. I already have my VRF setup, right, from my earlier video. I haven't removed them. There is connectivity, like I can show you that there is connectivity between R3 and R4. Let me do a ping, right, 10.3, sorry, 10.2.2.4, right? If I want, let me source it from 10.1.1.3. So I'm pinging from R3 to R4. There you go, there is connectivity, right? So and you can check the routing tables for my customer A. Show IP route VRF customer A. There you go. On my R1 I do have the VRF setup, and the VRF which I'm interested in now is particularly called as customer A, and I have my routes, everything up there, right? So now we are just left with doing the VPN configuration, the IPsec or the crypto configuration. So let me just pull that up from here, and let me explain what I'm actually doing up there, right? Great. So let's go inside the config mode. There you go. So this is the configuration which we'll be pasting now, right? So what do you do here? So VPN configuration, the phase 1 configuration is again the same to some point of it. Like for example, we have seen this part of the configuration done before as well. I'm doing this on R1, just to recap, I'm doing this on R1. So I have the ISAKMP policy being set, then I'm also telling the authentication will be done by a pre-shared key for my first phase, right? Then I have a hash encryption and the group 2 again corresponding to the Diffie-Hellman keys, right? So this was all there earlier as well, right? Now this is where the changes come into picture. So earlier we used crypto ISAKMP key, and we put in a particular pre-shared key, we put in the address, right? We put in the address of R2, but we can't do that. Why? Because the address doesn't reside in the global routing table, right? So we define something called as a, there are two extra steps which we do here. These are the two extra steps. The first step is called as the keyring, and the other one is the profile, ISACM profile, right? So what we did here is we created a keyring, right? So KR1, we're calling this keyring as KR1, and we are attaching the, referencing the VRF which we are interested in, which is customer A, right? And now we put in the pre-shared key, right? Since the pre-shared key which will be used during my phase 1 authentication is basically put in here, and the pre-shared key is basically Cisco 123, and the address of R2 is basically 10.12.2, this particular serial interface, right? So we define keyring, and then we also define something called as a ISACM profile, right? So in this ISACM profile, again, this all these names are basically local to the router, so you need not, you can use any name on either of the routers, it doesn't matter. This is important. You need to, under the ISACM profile, you need to again mention the VRF which you are interested in, then define your keyring which you earlier created over here, right? So we are again attaching the VRF and the keyring, and the last part is nothing but we are talking about the address of R2 here, right? So the identity address has to be mentioned, saying that 10.12.2 is the router with which you have to establish the phase 1, right? Don't forget to mention the customer A again, right? So these are the two steps which have to be done in addition when you are doing VRF aware VPNs, right? So one is the keyring and the other one is the ISACM profile, okay? Then we have the phase 2, which is pretty much the same as earlier. We define the triple DES and MD5 parameters here, right? And once we are done, so you know that phase 1 and phase 2 they create their own security associations. Now once that is done, we need to create a interesting traffic, right? Because I'm on R1, I'm defining this ACL for the traffic which is going to originate from behind the R1 towards R2, right? From R3 to R4 basically. So I'm telling my source address to be 10.1.0 and the destination to be 10.2.20, which is nothing but my R4, right? When I do this on R2, when I do the same configuration on R2, the ACL will be flipped, right? Because the traffic we are talking then would be going from R4 to R3, or it would be going in this direction. So you need to define 10.2 first and then 10.1 second, right? Now it is on R1, so this is right. The last part is again crypto map, which we have done before, right? You define a crypto map, put in a sequence number, you tell that please use ISACM for phase 1 over here. Then you attach your ACL which you created, match address 101, right? You set the peer, which is 10.2.2, and you set 10.12.2, 12.12.2. Then you also attach your phase 2 configuration here, right? And don't forget to put in your ISACM profile, right? So the ISACM profile which you earlier created, right, using those two extra steps, right, you need to go back and attach it to your crypto map. That is the whole reason why we created the ISACM profile, right? And the last part is nothing but you go to the outgoing interface, which is 2/0, and put in the crypto map, which is good. Let me pull this up. Yeah, I have put that on R1. Now we'll have to do the same thing on R2 as well, right? So let's do that. There you go. Everything remains the same. Phase 1 till here is same. Phase 2 keyring configuration is same, except the address is going to be different because the peer for R2 is R1, so you need to define it as 12.12.1, right? So because you're explicitly telling exchange this key with the other router, right? Use this key for authentication with the other router, which is R1. Then you again define the ISACM profile, right? Which is all of this is same. Again, the address over here would be different because we are talking about phase 1 configuration, and the peer is nothing but my R1 over here, right? So you're using the R1. Earlier we used R2 in the earlier configuration, right? Phase 2 remains the same. Interesting traffic, now the IP addresses are flipped, right? Earlier it was 10.1 going to 10.2, now it is 10.2 going to 10.1 because we're talking about the traffic going in this direction. Crypto map has to be created, right? CryptoMap again has the same thing inside, right? Set peer. Okay, this IP address will change again. Phase 2 remains the same. CryptoMap customer A ICCM profile A, right? That is good as well. You need to attach your ICCM profile back to the CryptoMap. You go to the outgoing interface, which is 2/0, and you apply it, right? So there you go. We have applied everything. Is pretty good, right? Now let's go and see how it looks. Let me clear the screen. Let's see. See the phase 1 tunnel. Show IP. Okay, show crypto, right? Show crypto ISACMP SCA. There you go. So the phase 1 tunnel has not been created. Let me also look at my phase 2. Show crypto IPsec SCA, right? So you see there are no packets which are exchanged yet, right? Now what I'll do is I'm going to do a ping from R3 to R4, right? When I do a ping from R3 to R4, there will be traffic moving along this, and it will be encrypted, and we can see if it is really getting encrypted by running the same commands which we ran earlier, right? So let's do a ping to 10.2.2.4, right? I'm going to source this from 10.1.1. maybe 3, right? So the ping was successful. Now let's go and see the output of these two commands again, right? Let's see the phase 1. There you go. The phase 1 tunnel has been created, right? There is a tunnel which is from R2 to R1. Yeah, source is R1 and destination is R2, right? Because the traffic was going in this direction. So the phase 1 tunnel has been created. Let's see the phase 2. There you go. So the phase 2, it's explicitly telling that this is for customer A, and we have the ACL as well, which we defined, right? 10.1 to 10.2, and you can see the packets here, right? 4 packets, which is very much in line with what we did here, right? 4 packets went across R3 and R4, and that is what is getting encapsulated over here, right? Which is pretty much the same. Again, you have the key, phase 1 keys, which was which will be used in phase 2 for my encryption, right? So it looks pretty good, right? Both my phase 1 and phase 2 was created, and then the packets are also encapsulated and encrypted, right? Which is pretty good. I think, yeah, that basically covers what I wanted to show you. This is nothing but VRF aware VPNs, right? Thank you.